All right. We start this one with a thermochemical equation. Calcium plus 2 hydrochloric acids yields calcium chloride and hydrogen gas and 418.8 kilojoules of energy. And the question wants to know how many grams of calcium so that's our unknown. How many grams of calcium would it take to react with excess HCl? So there's plenty of HCl. I don't have to worry about that in the problem at all. So if they're reacting in 100 grams of water, and how many grams would it take to raise that 100 grams of water by 25 degrees Celsius? Okay, so I know that that's going to take some amount of energy, right? To raise the temperature of the water, I have to put in energy, and that amount of energy we would call Q, right? Because it's being transferred, it's the heat that must be absorbed by the water in this reaction. So I need to figure out, let's see, what do we know? We know we're solving for grams of calcium. We know that for every mole of calcium, you get out of the reaction 418.8 kilojoules. I know that some amount of energy, some slice of 418, has to go into water to raise its temperature by 25 degrees Celsius. So, let's see. If we have enough information to figure out how much energy it would take to raise 100 grams of water by 25 degrees Celsius, then I could find that amount of energy, relate that amount of energy to the reaction. Energy relates to moles of calcium relates to grams of calcium. So I think that's my way to do it. I gotta find Q, involved in heating up the water, Q to energy, energy to moles of calcium to grams of calcium. All right. So I know change in temp, I know mass, and I know the specific heat of water. It's 4.18 joules per gram degree Celsius. All right, and Q equals S times M times delta T. 4.18 times 100 times 25. Q comes out to be 10,450 joules. Okay, so that's the amount of energy I'm shooting for. So I need to know how that relates to then grams of calcium. So I'm going to set up a chain of calculations. So we're going to go 10,450 joules times, I got to convert it to kilojoules. So it's 1 kilojoule for every 1,000 regular joules times, then I know that it is, kilojoules can go on the bottom. So let's see, we got energy in kilojoules. Now it's time to go to moles. So 1 mole of calcium for every 418.8 kilojoules times, then it's 40.08 grams of calcium for every 1 mole of calcium. True statement, true statement, true statement. Units cancel. I'm left with grams of calcium. 10.45 divided by 418.8 times 40.08, I get 1.00 grams of calcium. All right, so then let's say I get an answer. All right, 1 gram of calcium. Seems okay. I mean, I know that this number is way too big for this number, so it's not going to be a whole mole of calcium. It'd be some slice of a mole of calcium, so that makes sense. But if I don't trust that number, if I'm not sure about it, take that number, put it in here, and figure out, with 1 gram of calcium, how much energy would be produced. If that energy went into 100 grams of water, how much would it raise the temperature? And if it works out, you work the whole cycle backwards and you get 25 degrees Celsius, it's very unlikely that you could have made the exact same mistakes on the backward trip as you did on the forward trip. So if I put my number back in and it checked out when I reworked it, I would be 99.9% sure that I had the right answer.